Welcome. In this video, we are going to explain the spanning tree protocol. We're going to look at Cisco's definition of spanning tree. We're going to explain the purpose of spanning tree, how spanning tree has evolved over the years. We're going to look at the different types of spanning tree and why spanning tree is necessary. Here we have Cisco's definition of spanning tree. Spanning tree prevents loops from being formed when switches or bridges are interconnected via multiple paths. The spanning tree protocol implements the 802.1d IEEE algorithm by exchanging Bpdu messages with other switches to detect loops, and then removes the loop by shutting down selected bridge interfaces. The algorithm guarantees that there is one and only one active path between the two network devices. All right, the evolution of spanning tree. The first version came from the old hub bridge era, and over time, the convergence speed has become more and more important. And that's due to VoIP and other low latency applications, demanding that the switched networks converge very, very quickly. All right, so IEEE 802.1d is the original protocol from the era of hubs and bridges. It's also referred to as common spanning tree, and it allows for one instance for all VLANs. And then we have PVST and PVST+, so this stands for per VLAN spanning tree. PVST without the plus is supported on ISL, which is inter-switch link. It is a Cisco proprietary trunking protocol. And then PVST+, which is going to be more common, is what you would use with the .1Q trunking. And so both of these allow for an 802.1d instance of spanning tree for every single VLAN. And this is opposed to common spanning tree when there is just one instance total. This means that each VLAN will have its own route and perform its own calculation, and each VLAN will send out Bpdus every 2 seconds. Then we have multiple spanning tree, also known as MSTP. This allows you to map multiple VLANs to a single spanning tree instance. This works really well in cases where you have a high number of VLANs. And let's say you had 20 VLANs, you'd be able to map 10 of those VLANs to one instance to prioritize one exit point, and 10 of the VLANs to the other instance going out the other exit point. Rstp, which is rapid spanning tree, is also built into MSTP, so it converges very quickly. And MSTP works the best when there is a large number of VLANs. Rapid spanning tree, or Rstp, improves upon the convergence time compared to the 1998 version of spanning tree. It allows for much quicker convergence, but allows for only one instance of spanning tree. And then you have the combining of rapid spanning tree and PVST+, so you get both the benefits of the fast convergence, and you get one instance of spanning tree for each VLAN. So when is spanning tree necessary? It's when you have multiple links between the switches. So the picture I have here is about as basic as it gets. It has a PC, each connected to a switch, and then there's dual links between the switches. So in this scenario, you would need spanning tree. However, if you only had one link between the switches, spanning tree wouldn't end up doing anything. But the reality is, in most switch networks, you're going to have dual links between the devices, which means that spanning tree is really ubiquitous in the real world. Then bridge protocol data units, BPDUs. These are the messages that spanning tree sends out to the other switches in order to communicate. They're sent out every 2 seconds. They contain the bridge ID value. It carries the spanning tree information. And there's 3 different types of BPDUs. The first is the configuration BPDU, which is what's used to build the spanning tree topology. Then the topology change notification, which is what happens when a link goes down or a link is added. Topology change notification messages get sent out, and essentially spanning tree ends up reconverging and calculates the route again. Then there's the acknowledgement BPDU, just so that the sending switch knows that the messages it's sending out are being received. All right, so that was really just a brief flyover of the spanning tree protocol. We're going to be doing more in-depth labs looking at different scenarios and each of the types of spanning tree individually. If you found this helpful, please consider liking and subscribing, and I will see you in the next video.